if you can remember all the way back to SM1, you learned about systems of equations. They were all linear, and what we were looking for is where did our two lines intersect? What was that point of intersection? Now, what we're going to be looking at is systems of non-linear equations. So this gets a little bit more intense algebraically. Graphically, we're looking for the same thing. Okay, we just want to know when our equations equal the same thing at the same time. In other words, where do they intersect? Okay, so what we're going to start out with is I'm going to actually start with a system of two equations. So we're just going to focus on these upper two equations right now. Okay, so I'm going to switch over to Desmos so we can see that over here on our side screen and see our graphs come into play. Okay, so what I'm going to type in here is I've got my y equals log base 4 of x. So we get our graph. I'm going to go ahead and move that over here in a second. We'll just, let's see, make sure that's lined up. I can now see that you can see the board. That's all I care about, really. Okay. Yes, there's lots of Miss Nelsons again. That's right. Okay, yeah, okay. So we can see our log graph here. And now I'm going to type in our cubic, which was y equals x minus 4 cubed plus 1. So what we can see here, I'm going to go ahead and zoom in a little bit on our graph, is we can see that our graph is intersecting in 3 different places. All right? So our Desmos is showing us where those 3 graphs, or those 2 graphs are intersecting. So I have the points. So we have 3.563 and 0.917. That's one point. Then we've got another point. They intersect at 4,1. And then I have a third point at 4.414 and 1.071. All right. So what we're dealing with here is we have 2 functions, and I want to know where they're equal. Where do they intersect? These 3 points are all solutions to that system. That's it. I want to know where those 2 equations intersect, and in this case, 3 points. So now what I'm going to do, if you guys remember, I have my second equation, or my third equation over here, is we're going to bring that third equation in and see how that changes things. Okay? So now I want to have a system of 3 equations. We've already got these 2 graphed. I'm going to bring in this third graph and see what happens. Okay, so we're going to move this over. Infinite me again. All right, so we're going to type in now, this is x minus 4 squared plus y plus 1 squared equals 4. Okay, and what we're seeing here is we're seeing a circle. Okay, has a radius of 2 and a center of 4, -1. We got a lot going on here, so I'm going to zoom in. And we can see that the green line intersects the red line here, but the blue line doesn't. Oops. Touched a button I didn't want to. Got too close. There we go. And then over here, blue line and red line intersect, but the green doesn't. But right there in the middle, all 3 of my graphs intersect at the point 4, 1. So what I'm looking for when I have a system of 3 equations is where all 3 graphs intersect at the same point. So when I'm using all 3 of these equations that I have listed, the only solution I'm going to use is 4, 1. All 3 of my graphs intersect at that point 4, 1. So when we're dealing with these systems of nonlinear equations, all we're looking for is where do my points intersect. Simple enough? If you've got questions, let me know.